Greetings. Good morning or good afternoon, depending on when you're looking at this. But let's jump in. Excuse me. We're going to be talking about here in week 4. Okay. And we're going to be talking about routing fundamentals and moving data between networks. Before we talked about switches and VLANs, and now we're going to the next step is, we're getting outside the realm of the VLAN and getting into the area of how do I get it once it's outside the VLAN, how do I get it to its destination? And we do that via routers. So what we have here, we have router fundamentals. We're going to cover first IP routing basics, routing tables, what they're used for, static routing, default routes, packet forward process, practical applications. Those are the areas that we're going to be touching today. Okay, so let's talk about router fundamentals. A router connects multiple networks and forwards packets based on the best path to get to the destination that needs the data. Okay, so if you look at key functions, we got connects different networks, links in multiple networks, chooses the best path. There's a process where we actually determine what the path determination process is. We have packet forwarding, forward packets to the next hop. Key thing about a hop is that to get from point A to point B, we might have to do interim stops that will route us to a different location. So I might take A and I hit router 1. Okay, that's hop 1. Then I might hit hop 2, and hop 2 sends me to router 25. Okay, and then in 25, I do another hop that gets me to my final destination. So these hops that we do in the packet forwarding is a process of following the path that the router has determined. And basically, periodically, we're having to go not directly to our location, but to go to interim hops before we can get to what we want to be. Traffic management helps manage congestion and optimize performance. So if we look at a particular router, okay, you probably have a router in your home or in your room as far as connecting outside of the LAN, outside of the LAN. Okay. So here with router fundamentals, the router connects multiple networks and forwards packets based on the best path. Okay. So typical router components, interfaces, physical ports that connect to different networks, routing engine, okay, processes routing information and determines paths, and memory stores routing tables and configuration. Okay, so we look at some common router interfaces. Ethernet, best known here is RJ45. Serial WAN, okay, wide area network, fiber, and wireless. Okay, so those are the mediums that we go across that the router actually connects to. The key takeaway: routers determine the packet destination. Information used use routing tables and determine the best path to the next hop. So in the routing table is the direct path. It's not the direct path, but it's the path and the hops that the data is going to have to take in order to get to its final destination. That is in the routing table. Okay, routing basics. Okay, how IP routing works? And basically looking at here for a routing example, we're taking some information, we're moving it from PCA, okay, and we're going to router 1. Router 1 sends it to router 2, and router 2 sends it to PCB, which is who wants to receive the information. So we start out with an IP address of 10.0.0.10, and it's going to IP address 192.68.10. Okay. During this, depending on the process, we might go into other routing scenarios. Here, basically showing internet and other internet and other networks. Okay, important concepts. Okay, down here, basically looking at a network, a group of devices that communicate directly. Okay, that's a network. The gateway, the router interface that connects to a particular network, gateway into another router. Next hop, the next router or destination towards our final target. Okay. And then 0 hot content, the number of routers in the packet that passes through. So as your data is passing through the network and it's hitting various hops or various stop points, all that's going to be recorded. Okay. And so basically, once it gets to its final destination, you'll be able to see all the paths that it took and all the hops it had to do in order to get to your destination. That is because that the path that we normally think that we're going to take may not be possible. Okay, it may not be possible. Something may have happened along that route. So what we may have to do is take a detour, and with that detour, we're going to maybe or possibly a different place, a different hop, in order to get to our final destination. So just because we lay out a particular route in the routing table, if something happens where that route cannot be completed, the system will automatically, through the various routers, take alternative paths in order to get the data still to its final destination. The routing tables we talked about basically have information as to what is our destination network, subnet mask, where are we going to have to go through subnets in order to get to our information. So here we're talking about a routing table example, the destination network, the subnet mask, the next hop. Okay, where am I going next? Okay, once I get to this location, and the exit interface along with a metric value. So this is basically, once I look at this, I'll be able to know this is what basically the network will use to determine how I'm going to get from point A to point B. What's the submask? What are the networks that we're going to have to go through? Now, what are the stops or hops, okay, that we're going to have to go through in order to get our particular piece of data to its location? Okay, routing table components, destination network, kind of obvious. The network or host the routers for. Subnet mask defines the network portion of the address. Yeah, there's several networks that we might have to go through. Okay, the subnet basically says, okay, our primary network that we're going to go through is defined in the subnet mask. So how I determine which network I'm deciding to go to is defined in the IP address as far as the network mask. So that's what's basically here, where we can go look at the IP address, and that will basically tell us which network we're going to. The next hop, IP address of the next router or destination. The exit interface, the interface used to end the packet, to send the packet. Okay, and metrics, the value that represents the cost to reach the destination. So that's the metric that we're showing here. Now, from get to point A to point B, what is it going to cost? How many stops am I going to have to make? If I'm assuming I'm not static, which we're getting ready to talk about next. Okay. How expensive is it for me to get from point A to point B relative to the number of things I have to go through in order to get to that destination? Routing table types, got directly connected networks and remote networks. Networks learned via static route codes or dynamic routing protocols. The key thing here is that we basically record everywhere we're going, everywhere we need to go. Okay, so with that, the key takeaways. Excuse me. Routers examine packet destination information to be used for routing tables to determine the best path to the next hop towards our final destination. Oh, excuse me. Okay, static routing. Okay, static routing. Static routing is basically used when we do not want um, the route to be changed. That from at point A, we want to go to point A, then to point B, then to point C to our final destination. That's static. Can't be changed unless I reconfigure it. The issue with that is if something happens along the way to where that connection between any kind of interim stops between till I get to my final destination, if for some reason it fails, there is no guarantee that the information is going to get to its final destination because I can't change the route. Static routing says I have my path. It's the shortest path route. Here's what you want to use. If something happens, tell me. Okay, but don't change the route to try to bypass the problem. Okay, used with small networks, simple topologies, stub networks, only one exit point, default routes to the internet. When routing updates are not needed, which means I'm in a situation where I don't think I'm going to have to worry about changing which hops I go to. And then for security and control purposes, you might want to put a static routing that will go on the table that is basically etched in stone as to how I'm going to get from point A to point B. Static routing. Default routes. Safety net for unknown destinations. A default route is used when a router does not have a specific route to destination network. It sends the packet to a default gateway. So if I have a situation for some reason, okay, I haven't identified the network that I'm going to. Okay, that maybe sometime down the road, I'm going to connect and it's going to tell me what network to send it to. Okay, it sends the packet to a default gateway. Okay, so here talking about no match found, how the default works. I didn't find a match on if the destination network is not in the routing table. Okay, so I can't find it. I can't look it up to say this is the route I want to take. So it uses a default route. The route sends the packet to the default next hop. Okay, reach the internet, the default gateway forwards the packet towards the internet, or some other network. So I'm actually just sending that information to another source that says, hey, can you give me, it's not in my table. I don't know what destination it is. But when it sends it to the gateway, there's some analysis that happens to say, okay, we're going to look up the destination for you on this particular instance. And then it's going to have basically putting in the information that we couldn't get. So that default gateway is basically a backdrop or a process where if for some reason I don't have that network, which is going to be few and far between, but there are cases where I don't have it, then I'm expecting it to be filled in somewhere down the road. So that's what these are default. Default is used when a router does not have specific route to a destination network. It sends the package to the default gateway. And the default gateway goes through the process of trying to figure out the route that it should take. Okay, when do you want to use default networks, default routes? To reach the internet, to reduce routing table size. You can't get everything about everybody in the table, so you're limited to it as to which routes are in there. For backup or as a last resort of connectivity. I have to get from point A to point B. I don't have the destination information, so I have to use a default route. Okay, and that's the default route when I don't have that destination. Routing packet forwarding process. The key thing here, the 7 steps. Okay. The packet arrives, the router receives the packet on an interface. It does a layer 2 check. The router checks the layer 2 frame and verifies that the destination and verifies the destination MAC address, which is the physical device. Does the device actually exist? Okay, it will be on this routing packet. Remove layer 2 header. Okay, the router removes the layer 2 header. data link layer, check layer 3 header, routing table lookup, forward the packet, and repeat. Okay, so these are the basic 7 steps that it will go through to try to, once it receives the packet for processing, what it goes to in order to send it to that final destination of the actual device that's going to use it. Okay, here sort PC to router 1, which goes to router 2. Router 2 sends it to the destination. So we're forwarding that packet. Here, this is just a layout of what we described up here. Key points, router operates at layer 3. Okay. Again, when we talk about these layers, my expectation is maybe you have a little cheat sheet. Say, here's my OSA layers. So you immediately know what is layer 2, what is layer 3. Okay, so operates at layer 3. Each hop repeats the process. The best path determined by the routing table. So there's a lookup that says, what's the best way for me to get point A to point B? Okay, and that's in the routing table. Key takeaways: the packet forwarding process ensures that packets travel across networks quickly and reliably using the best available path. This is analysis. This is just not a table with static information. This is basically, I'm going from here to hop 1, hop 2. When I go to hop 2, it might take me to my final destination, but something happened with the network and I go to hop 3. Okay, so this is dynamic in that it will change as far as whether the path that I'm going to take through the various networks, whether I can do that and without having any issues. Okay, some practical applications. Connecting to offices, departments, data. Okay, ensure resource sharing, internet access, remote branches, cloud environments, service providers. The key benefits of routing, reliable network connectivity, efficient use of bandwidth, scalability for future growth, improved security and control, and high availability. Again, a router, when you think of router, think of changing paths, direction, moving packets of data to different places, okay, which may or may not be your final destination. Okay. Okay. Okay, expectation is you'll review this. Again, look at the highlights as far as the quiz that we're going to be setting up for this week 4. And so hope if you have any questions, let me know. If not, I will see you on Thursday as we go into week 4 routing. Have a good one. Bye.